Hello and welcome to Tech of the Day. Today we are going to talk about develop message based solutions. In the previous video we talked about develop event based solutions, and this video is about develop message based solutions. There is difference, and there are many similar words which if you don't pay attention are similar and sound like they are doing same work. But as we discussed in the previous video, like Azure Event Grid, Azure Event Hub, Azure Notification Hub, and the difference between all of them, same way you need to watch this video to know more about and the topics. Azure Service Bus, Azure Queue Storage, Microsoft Graph, and Azure Relay. And we are not going to do the lab actually, but you going to do the lab. So you are the one who will be doing it. I'm just putting it here. But stay tuned if you want to learn about Azure Service Bus, Azure Queue Storage, Microsoft Graph, and Azure Relay. Let's get started. Azure Service Bus. What is Azure Service Bus? In this lesson, we will cover Azure Service Bus, event versus messaging services, queues, topics, and subscription, and message payloads and serializations. Azure Service Bus. So, what is basically Azure Service Bus? Azure Service Bus is a fully managed enterprise integration message broker. Service Bus is most commonly used to decouple applications and services from each other and is reliable and secure platform for asynchronous data and state transfer. Data is transferred between different applications and services by using messages. A message is a binary format which can be like JSON, XML, or just text. A namespace is a scoping container for all messaging components. Multiple queues and topics can reside within a single namespace, and namespace often serve as application containers. Some messaging scenarios are messaging, so where transfer business data such as sales, purchase orders, journals, and inventory movements. Decouple applications, and topics and subscriptions, which enable one-to-one relationships between publisher and subscribers. Message sessions implement workflows that require message ordering and message deferral. Events versus messaging service. So, an event is a lightweight notification of a condition or a state change. The publisher of the event has no expectations about how the event is handled. The consumer of the event decides what to do with the notification. Events can be discrete units or part of a series. Discrete events report state change and are actionable. To take the next step, the consumer only needs to know that something happened. The event data has information about what happened but doesn't have the data that triggered the event. And let's say, as we discussed in the previous video, you have a drop of a file in Azure storage. That means that's an event, and then you want to trigger that event, and then you need a subscriber to that event. A message. Then what is a message? A message is a raw data produced by a service to be consumed or stored elsewhere. The message contains the data that triggered the message pipeline. The publisher of the message has an expectation about how the consumer handles the message. A contract exists between the two sides. For example, the publisher sends a message with the raw data and expects the consumer to create a file from that data and send a response when the work is done. So you understand, event is simply an something happened, but message is not a like event. So you need to understand now. So event grid is reactive programming. Let me make the laser pointer. Event hubs, big data pipeline, service bus, high value enterprise messaging. So these two are event based and this is message based. So order processing, financial transactions. This one is telemetry and distributed data streaming. React to status change. So event grid, react to status change. Queues. Next comes queues. Queues offer first in first out FIFO message delivery to one or more competing consumers. That is, receivers typically receive and process messages in the order in which they were added to the queue, and only one message consumer receives and processes each message. A key benefit of using queues is to achieve temporal decoupling of applications components. In other words, the producers and consumers do not have to be sending and receiving messages at the same time because messages are stored durably in the queue. Furthermore, the producer does not have to wait for a reply from the consumer in order to continue to process and send messages. A related benefit is load leveling, which enables producers and consumers to send and receive messages at different rates. In many applications, the system load varies over time. However, the processing time required for each unit of work is typically constant. And another message here can be like your application send a message which triggers some calculations which takes a lot of time, and at the other hand you cannot wait for that reply from your another application. So what you do, you just continue executing your other tasks and you put your message in the queue. So here you see sender send the message and message is in the queue with messages, and when receiver is available it receives the message. Queue based load balancing, load leveling. So because the message is in the queue, so your queue is balanced, your load is balanced because use a queue that acts as a buffer between a task and a service it invokes to smooth intermittent heavy loads that can cause the service to fail or the task to time out. This can help to minimize the impact of peaks in demand on availability and responsiveness for both the task and the service. So it can help you to gain the high availability because your application is not dependent then, because this is not tightly coupled, and your message is stored, it's not lost. So if your receiver is busy and you send a message, it doesn't receive it, then your message is lost and then your app is not highly available, so and is not responsive. But if the message is stored here, and that means your request is in queue and you don't wait for it, you just continue doing other stuff and it does something and then you get the response. Perfect, right? So topics and subscriptions. As we saw in the previous video, Same here, you need topics and subscriptions. In contrast to queues, in which each message is processed by a single consumer, topics and subscriptions provide a one-to-many form of communication in a publish-subscribe pattern, useful for scaling to large number of recipients. Each published message is made available to each subscription registered with the topic, and messages are sent to a topic and delivered to one or more associated subscriptions. Depending on filter rules that can set on a per subscription basis, the subscriptions can use additional filters to restrict the messages that they want to receive. Messages are sent to a topic in the same way they are sent to a queue, but messages are not received from the topic directly. Instead, they are received from subscriptions. A topic subscription resembles a virtual queue that receives copy of the messages that are sent to the topic. So subscriptions are independent, which allows for many independent taps into a message stream. Message payload and serialization. Messages carry a payload and metadata in the form of key value pair properties, describing the payload and giving handling instruction to service bus and applications. Occasionally, that metadata alone is sufficient to carry the information on that sender wants to communicate to the receivers, and payload remains empty. The object model of the official Service Bus client for .NET and Java reflect the abstract Service Bus message structure, which is mapped to and from the wire protocol Service Bus supports. A Service Bus message consists of a binary payload section that Service Bus never handles in any form on the service side, and two sets of properties. The broker properties are predefined by the system. These predefined properties either control message level functionalities inside the broker or map to common and standardized metadata items. You also have payload serialization. When in transit or stored inside Service Bus, the payload is always an opaque binary block. The content type property enables application to describe the payload with the suggested format of the property value being a MIME type. MIME content type description according to standard rule. When using the legacy Simple Network Management Protocol SBMP, those objects are then serialized with the default binary serializer or with a serializer that is externally supplied. So what is serialized as opaque? Binary content can be deserialized by using SDK libraries, gives the flexibility to explicitly define how you want to serialize the content. So demo. So I want you to do a demo which will contain create a service bus namespace and queue by using the Azure CLI. So what you need to do, create a service bus namespace and a queue by using Azure CLI. Write a .NET Core console application to send a set of messages to that queue, and write a .NET Core console application to receive those messages from the queue. So you create a queue, and then you write a sender in .NET Core, and you write a receiver in .NET Core. It's simple. both these receiver and sender should be in console application. So just simple testing. And this thing to create a queue using Azure CLI, you can do it easily. Azure queue storage. In this lesson we will cover queue storage, and we will give some examples. So what is Azure queue storage? Azure queue storage is a service for storing large number of messages that can be accessed from anywhere in the world by authenticated calls using HTTP or HTTPS. A single queue message can be up to 64 kilobytes, and a queue can contain millions of messages up to total capacity limit of the storage account. So because your queue storage is connected to a storage account, so that depends on the capacity of your storage account. Common uses of queue storage include creating a backlog of work to process asynchronously passing messages from Azure Web role to an Azure Worker role. What are the components of this? So you have URL format, you have storage account, you have queue, you have message. So what is URL format? Queues are addressable by using the URL format, which is storage account name .queue.core.windows.net / the queue. And the storage account is all access to Azure storage account is done through the storage account. A queue contains a set of messages. All messages must be in a queue, and message is in any format up to 64 kilobyte. So here are some code example where you have the connection string to the storage, then you create the cloud storage account using the connection string using this key, and then you create a queue client using this account. So create cloud queue account client using this account you just created using the storage connection string, and then you retrieve the reference. So you create it and then you retrieve the reference, get queue reference with the name, which is name of your queue, and then create the queue if it doesn't already exist. So queue.create if not exist. Simple. Now you create the message. So you create a new message, a cloud message, cloud queue message, and you add this cloud queue message to the queue which you just created here, and add this message to that queue and peek the next message. So you take the first message from the queue and then fetch the queue attributes and cast message count, queue approximate message size. This is just simple operation. So you see it's very easy. Then you can retrieve the message and change it as well. So cloud queue message, retrieved message, you get the message and then you can delete it. You can update the message content. So you just say queue.update message, which is the new message you got, the existing message, time span from seconds, for you can just say for how much time, and then visibility. Easy, right? Next is Microsoft Graph. Very good topic. In this one we will cover Microsoft Graph. Microsoft Graph as a data gateway relationship in Microsoft Graph. Using Microsoft Graph, Microsoft Graph request, query with Microsoft Graph, watch with Microsoft Graph, observe extensions in Microsoft Graph. Let's go. Really good one. So what is a Microsoft Graph? Microsoft Graph is the gateway to data and the intelligence in Microsoft 365. The Microsoft Graph API offers a single endpoint, which is https graph.microsoft.com, to provide access to rich people-centric data and insights exposed as resources of Microsoft 365 services. You can use representational state transfer application, programming interface, REST APIs, or SDKs to access endpoint and build apps that support scenarios spanning and across productivity, collaboration, education, security, identity, access, device management, and much more for your applications. And you can use Microsoft Graph API to build apps for organizations and consumers that interact with the data of millions of users. With Microsoft Graph, you can connect to a wealth of resources, relationships, and intelligence, all through a single endpoint, graph.microsoft.com. So it's like Azure Active Directory, but with a little bit difference. We will talk about it. Microsoft provides a unified programmability model that you can use to access the data from Office 365, Windows 10, Enterprise, Mobility plus Security, client libraries to access data from Azure Active Directory, Office 365, SharePoint, OneDrive, Outlook, Microsoft Teams, OneNote, Planner, Excel, education. So Microsoft Graph supports organizational accounts, corporate and educational, along with personal accounts, and you'll learn how they use them. So you have Office, Windows, Enterprise plus Security. Then you can then connect with applications such as web apps, device, boards, background processes. So it's really good. Relationships in Microsoft Graph. Very interesting. Microsoft Graph connects all the resources across these services using relationships. For example, a user can be connected to a graph through a member of relationship, and to another user through a manager relationship. So your app can traverse these relationships to access these connected resources and perform actions on them through the API. You can also get valuable insights and intelligence about the data from the Microsoft Graph. For example, you can get popular files trending around a particular user, or get the most relevant people around the user. So simply, it's a graphical representation of employees of your organization. Using the Microsoft Graph, keeping company directory information up to date is key concern for many organizations. You can use Microsoft Graph to update profile information stored in various locations via single endpoint. Update profile photos stored in 365, directly information in Azure Relay, and profile information in SharePoint Online via Microsoft Graph APIs. You can use the same APIs to query or profile information. So you can use Graph API to get all the information about your employees. This is an example. Some queries against Microsoft Graph return multiple pages of data, either due to server-side paging or due to use of top query parameter to specify limit the page size in request. When a result set spans multiple pages, Microsoft Graph returns OData next link property in the response that contains a URL to the next page of the results, and then you can use that thing. So you send a request to this, then you get the OData next link with this URL, and then you can get it. Query with Microsoft Graph. Get the user profile. Let's say you want to get the user profile, user med, and then you want to get the information. Then you just simply say users, and then you just get the user. Then you get the user photo. Then you say users manager, and then you say direct reports to member of. So you can get many information like this. You can get the subscriptions and notification changes, extensions in Microsoft Graph. So basically Microsoft Graph is really useful, and custom properties, to extract custom properties as well. Microsoft Graph resources without requiring an external data source. Now Azure Relay. What is Azure Relay? Azure Relay is one of the key capability pillars of Azure Service Bus platform. The new hybrid connection capability of Relay is secure open protocol evolution based on HTTP and WebSockets. So in this lesson we will learn about Azure Relay. Azure Relay service enables you to securely expose services that run in your corporate network to the public cloud. You can do so without opening a port on your firewall or making intrusive changes to your corporate network infrastructure. The Relay service supports the following scenarios between on-premise services and applications running in the cloud or in another on-premise environment. Traditional one-way request response and peer-to-peer communication. Event distribution at internet scope to enable publish subscribe scenarios. Bidirectional and unbuffered socket communication across network boundaries. So Azure Relay differs from network relay integration technologies such as VPN, and Azure Relay can be scoped to single application endpoint on a single machine. The VPN technology is far more intrusive because it relies on altering the network environment. So you understand the difference. So it's request response and peer-to-peer communication over common protocols. Azure Relay Service Architecture. In the Relay data transfer pattern, the basic steps are involved, which are like an on-premises connects to the Relay service through an outbound port. It creates a bidirectional socket for communication tied to particular address. The client can communicate with on-premises services by sending traffic to the Relay service targeting that address. The Relay service can release the data to the on-premise service through the bidirectional socket dedicated to the client. The client doesn't need a direct connection to the on-premise service, it doesn't need to know the location of the service. Also, on the on-premise service doesn't need any inbound ports open on the firewall. So when the relay connection is established, the client can exchange messages via gateway node that is used for the rendezvous. In this Azure Relay breakdown, you see the first step is a client A creates a listening request that is routed to a gateway, and then a different client B creates a connection request to distinct gateway. Then this gateway creates a new relay, and then a different client B creates a connection request to a distinct gateway here. Then the connection request from client B is handled first by looking up the associated relay. After the correct relay has been identified, the request is forwarded to that specific relay. A rendezvous request is sent to client A. Client A creates a temporary channel to client B by using the original gateway that the client B used in its original connection request here, and client B can receive messages sent from A directly from its original gateway, and client A can receive messages sent from client B through its client B's original gateway. So then they have the bidirectional route directly like this. Before, to establish this route, they had to contact the gateway store with the Azure Relay, then gateway store, and at the same time client B made the request, and gateway store, and from the gateway store they found out the correct relay, and then the relay made the request, and then they found out the correct route. Clear? So to receive messages using .NET, here you need to get your token, shared access SaaS token with the name and key. Then you create a listener to a port, to an endpoint with the relay namespace and connection name. Then the listener is created using hybrid connection listener is creating using the URI and token provider, and then you can handle any incoming messages using this listener, and then you can open those Azure Relay service, and then you can close the listener. You see, simple receive messages, and then you can send messages as well. Same way you create the token provider URI, and then you get the token from this, and then you create the client, and then you create the HTTP request message with the request header service bus authorization with this token, and then you send the message. In this one we simply listen the message, but here we are sending the message. So to review what we did in this video, we talked about Azure Service Bus, Azure Queue Storage, Microsoft Graph, Azure Relay, and we did not do any lab. So but this lab is to be done by you. So the lab is to create a multi-tier solution by using services in Azure. That means you need to use all of the above terms in your solution, and you need to create a multi-tier solution. That means you have a problem which contains all of them in a single problem, and you need to find out a way to do that. I think you can do it because you already know the concept, and if you will do it yourself, you will really get deeper knowledge. But if you can't, then in my next videos I will be doing all the labs for AZ-203, because I didn't do many labs in my previous videos. I left actually, and but I will do all of those labs in my next videos, but it will take some time. That's why I'm asking you to do it. If you can do it, it will be perfect. And I hope you liked this video. So please like, share and subscribe, and please let me know in the comment sections uh, your feedback, and what is the next topic you would like to hear from me. And thank you for watching. Thank you.